Okay, go ahead and just pause this real fast and see if you can work through this problem. Okay, so once again, this is just like the one on the test. You do need to know Ag is a +1. I'm pretty sure we use carbonate. Carbonate is CO3 and it has a -2 charge. I don't remember if we use acetate, but do know acetate is C2H3O2 with the -1 charge. Okay, so the first step was to write and balance the equation, which I projected for you. So it wasn't too hard, I hope. We had 2 lithiums because it's a 1 and a -2. We had just a 1 Ag, 1 C2H3O2 because it was a 1 and 1. Now, I'm not talking about the coefficients yet. I'm talking about the formulas. Then 1 Li to 1 acetate and 2 Ags to 1 CO3. All right. So this is worth a couple of points. I can't remember what, but I think it's worth 3 or 4. I'd have to look at my rubric. Who was able to balance it correctly? Raise your hands. Okay, so that's a start. All right, then finding molar mass. Each one of these is worth some points. Who had all of those correct? Okay, so that's a good start. If you don't know where I got those, then you are definitely way behind the curve. It's 2 Ags from the periodic table plus 1 C plus 3 O's. All of those should add up to those values. If they're a little off, it's fine. I just Googled. I use Wikipedia. Go ahead.
Would it be bad if we round the molar masses?
You should use the molar masses that are matching the sig figs here. So there's 3 sig figs here, 3 here. I just kept the standard of 2 decimal places. And at the end, when I wrote my answers, they did add up to exactly 9.25, which is nice because everything at the end should add up to 9.25. You won't get in a lot of trouble, but don't round a lot. Be pretty specific. Okay, then to determine the limiting reactant. Hopefully this slide I have fixed everything. All right. What I did is I took both masses that were given. It gave me a mass of lithium carbonate, and I put it right there. It gave me a mass of silver acetate right here, and I started both of my picket fence with that information. I'm going to scroll up from here. So the top one, to get rid of grams Li2CO3, and I did go to one with more letters, you were right. LiC2H3O2. All right, so I guess I just went in order, whatever. It doesn't matter either way. All right, so to get rid of grams, LiC, whatever that is, I just put the grams down here. What's nice is if we already found these numbers, we don't have to do these while we're constructing the fence. We can just put a number we already know. Grams is always per 1 mole. Then I put 1 mole on the bottom from this coefficient. I put 2 moles on top from this coefficient. Then I took 1 mole on the bottom to get rid of it because grams is always that way. And then I used that molar mass, Li2C28, whoops, Li, oh, come on, Tom. And then I did the math and I got maybe 11.61. I don't remember if I screwed that number up or not, but it was bigger, I promise, either way. Okay, then the second one, I took my grams of silver acetate. To get rid of them, I divided them by their molar mass. That left me in moles. So I took their moles and eliminated them by using this coefficient. That's a 2. Then on the top, I'm going to what I want. That was a 2 also. So down here I had a 1. Then up here I had my 65 grams from here. Because anytime I write mole right there, it's per 1. I do the math and I got 1.19 grams of lithium acetate. I was left with 2 answers. To determine the limiting reactant, I look at the smaller mass produced and I find what I started with to produce it. So that tells me that my silver acetate is my limiting reactant because it produced the least amount of reactant. So the top one, you can see I've put gray lines through because I don't want to accidentally use those numbers ever again, right? Okay, then you should definitely do this. This red circle says this part of the picket fence will be used 3 more times. So why don't we just figure out this value and use it to save some time? We're going to make 3 picket fences. I guess, is it 2 more? Well, anyway, we're going to use it a lot more, right? Because really, the limiting thing isn't the grams of this. It's really the moles of this. Because remember, in order to talk one side or the other, we always had to go to moles anyway. So what I did is I just calculated this value and I brought it out here. And look, if you don't do this step, it doesn't matter. This is just to save you some writing, save you some time. Did you just roll your eyes at me, Stephen Jex? Yeah. Okay. All right. So this is the moles of my limiting reactant. You okay with that? It's just this front piece. So look, this number now will go right there, and we just have this part, right? Really, it's also always divided by 2, but then that makes the picket fence look stupid, and that just doesn't jive. Okay, so this is an answer, by the way, right? So let's do that so I can make sure I have these right. Li2, Li. All right. So which one is that one right here? Is that what we said? 1.19? Okay, good. Okay. So once again, I'm going to take this number, and I literally just cut and pasted it. And now I'm going to use my limiting reactant moles to solve for grams of the other products. There's only one other product, but it could be way more. But for now, it's just one other thing. So I have to solve for this now, correct? All right. So I took that number and I replaced the first part of the picket fence. I need to get rid of moles Ag C2H3O2. So I have a 2. Yeah. I have a 1. Then I have for every 1, 275.75. I do that math and I get 2.48. Was that this one, right? Can I go back far enough? Yeah. Okay. So remember, this piece right here, it saved me 3 grams and 166.91 for every 1 mole. That's what would be there. I just replaced it with what its answer already is. All right, so we now have 3 of the 4 of them, right? Because my limiting reactant is 0. Which one is my limiting reactant? Was it, which one? I don't remember. This one? Okay. So the final step now, the directions are right here. Use the limiting reactant to solve for grams used of excess reactant and then subtract from initial mass to find mass of excess. Okay, so once again, I'm using my limiting reactant, my little value I found of its moles. I take it, to get rid of it, I use its coefficient. Now I'm solving for this one this time. So it's a 2 on the bottom, a 1 on the top. Then to get rid of that mole, I put the molar mass of 1 on the bottom, 73.89 on top. And I wrote the word used before I even answered this, so I wouldn't screw up. When I do this, I get 0.665 grams used. A lot of people will then write that as their answer, but that is not the answer. The answer has to be found by subtracting what you just calculated from what you started with to find your excess. So I now have 5.58. And now I need to add all of those numbers together. I don't know if this matches what I had before, but I imagine it's really close. It should add to 9.25 grams. You add those up, we're going to be off just a tiny bit. No, we'll be right on again. And if that adds to 9.25, then you have a 99% chance you're correct. Why am I looking for 9.25? Because I started with 6.25 and 3. That makes 9.25. It is almost impossible to do this correct the long way and have it add to 9.25. The fast way, remember that at the end you could just find the leftover? Well, that will always add to the end because you assumed it did. But this way always gets you there. Okay. That took some work. I'm certainly aware of that. That took us 13 minutes to walk through. It took some of you, you're still probably working on it. But it's just, I got it right here actually. It's following these steps over and over. Every time you do the same thing. You balance it. You find the molar mass of each component because you're going to use them all. All right? Do it at the start, then you don't have to do it in a picket fence and lose track of what you're doing. Determine the limiting reactant by using 2 picket fences. Start with both reactants, solve for one product. Use limiting reactant moles to solve for grams of both products. All right? This step is kind of new. If you don't like that simplified step, that's fine. Don't do it. Just keep going 3 divided by 1 each, whatever it was. Then use that moles again to solve for the used excess, subtract from given, and then you're off to the races. Who thinks they understand this at all? Okay, who understands it really well? 1, 2, 3. Who has no clue still what they're doing at all? Just one of you. That's fine. You were sick, so I don't feel like I feel bad for you, but like I don't feel bad as a teacher. Sorry, that sounded rude. All right. Now, this is not the only thing that's on the test. The test is tomorrow, so let's make sure that you are okay with the rest. Let me shut this door. Okay, so the test has a section of multiple choice, and it has a section of what we call free response. This stuff is the free response. There's more of it, but let's just go ahead. Oh, this repeats itself 5 times because I changed my mind. Okay, so on the free response, the 1 through 3, you just have to write and balance reaction. Okay, I don't even know if it's that. Let me double check. It might just be naming 3 things. Nope, I was right. Right and balanced. What's that? Well, there's 3 right there. Okay, well, are you all right writing the formulas from words? Good, I wanted to crush your hopes. Okay, that's actually not 1 through 3. That's 1, A through C. Then 2 asks you, and I'll be out of order, but it doesn't matter, the percent like mg and mgo. It's different, but it just asks you to find the percentage of something. You don't know what that is? Oh my. 24 plus 16 equals 40. mg's 24 of it. Divide. 12/20 is 60%. Okay? Number 3 asks for atoms in like 5.2 moles. Something like that. How would you calculate that number? You multiply it by Avogadro's number. I'm seeing a lot of long faces. You are responsible to learn in this class. I am teaching and giving you resources at a high level, I promise. Like, I'm not going to take your hand and do this test for you or be at your house. Well, I am at your house, actually. I'm on your computer screen. If you don't know, like, if you don't know that, if you don't know that, and if you don't know that, then you haven't put in the effort even remotely close that this class requires. Okay, this number 4-ish, I give you percents, and you have to find the empirical formula of something. Yep. Grams, divide by molar mass, divide by smallest number, then you have your formula. Next, you have a combustion analysis problem. This one will take you about 10 minutes. Well, some of you will take 3 minutes, some of you will take 15. Let's just call it an average of 10. And then number 6 is a limiting reactant problem like we just did. The only difference is I changed the chemical formulas. Everything else is the exact same. You even start with 3 and 6. So tomorrow your stuff better add to what? 9.25. That is all of the free response, if I remember. The multiple choice. Every test has 2 from now on. There might be 1 or 2 that don't, I guess. But it's supposed to mimic how the real AP test looks. It's half and half. So this is from 2014. I have no idea if I'll feel like changing it or not. I have like 3 versions, so it probably won't be the same as this, but it'll be similar. Typically, I do not teach you the stuff from the multiple choice. It's from the reading. A molecule of water contains hydrogen and oxygen in a 1:8 ratio by mass. This is a statement of one of those laws. Which of the following is not one of the postulates of Dalton's atomic theory? I asked you this in a quiz earlier, a long time ago. The gold foil experiment performed in Rutherford's lab, yada, yada, yada. Isotopes are atoms that have the same number of blank but different numbers of blank. Elements blank exhibit similar physical and chemical properties. Which pair of the elements below should be most similar in chemical properties? How do we know if something is similar in chemical properties? It's in the same family, right? Same up and down column. Which of the following does not occur as a diatomic molecule in elemental form? That should be the question there. If you don't get that one right, then I should just fail and not have to correct the rest of the test. Because that's just memorizing a couple of little things, right? HNOFClBrI. Which one is the formula for hydrochloric acid? This 10 takes some thinking, but it says which formula/name pair is incorrect? Which one of the compounds is copper 1 chloride? Correct name for that is the nucleus of an atom contains. When a metal and nonmetal react, the blank tends to lose and the blank tends to gain. The charge of manganese in the salt MnF3 is, Tell your lab partner right now what the answer is. One person has any clue how to do that? Okay. So you can use the hop and swap, and it's probably a +3. You could also, in case you're a little nervous about that, you can say the charge of fluorine is -1. You divide that by the number of fluorines that there are. That's 3. Take the absolute value of that and divide it by the number of first atoms, which is 1, and you end up with a +3. Both ways work. I've never used this. The hop and swap, it's okay. Let's see, if it was MnO3, this would not work. This would be a +6. That's because it'd be -2 times 3 is -6 divided by 1. So the reason when the hop and swap might not work is if they were both even and you reduced them, or they were the same value. I don't really know how to get out of this. I've never used this tool before. It just all of a sudden started writing when I was touching the screen. Convenient, but whatever. Okay, I will tell you this will be really similar, and I will tell you that I'm recording this, and that it's recording the screen. So if you want to see these problems in slower motion, I would find wherever I put this video tonight, which will probably be somewhere in Guru and somewhere on my main page, to see how things work out. Okay, we have 10 minutes. Should we do a combustion analysis, or do you want me to give you another one of those limiting reactant ones? Let's vote quick. Limiting reactants, raise your hands. Combustion analysis, raise your hands. You just lost. Hardcore. All right, combustion analysis. This is from 2010. I have no idea what's about to pop up.
Oh, that's okay.
Hopefully it doesn't say, I hate this class. Oh, it's on this side. All right, so there are your problems. Your initial would be 2.225 grams CHO. Hey, and odds are high, you've already done this. Like, I don't know where, but we've probably found this same one. And you have a 50% chance it's CH2O, right? Almost all of them have been that way. Anyway, you end up in 0.512 grams CO2, 0.209 grams H2O. Now, I'm going to look real quick. No. I will tell you the answer is C3H6O. So you figure out, write that down, C3H6O. What am I looking for here? Wow, why did that pop in silver acetate?